All right, guys. So in this video, we're going to be going over the Unit 7 test review. Okay. Um, question 1 says, if triangle ABC has vertices with the coordinates 8, -2, -6, 12, and 4, 12, what are the vertices of triangle A prime, B prime, C prime under a dilation with a scale factor of 3/4 and the center at the origin 0, 0? So they give us the points A, B, and C. Okay. And all I'm doing is I'm taking these points, the pre-image points, and I'm multiplying them by my scale factor of 3/4. So A was at 8, -2. B was at -6, 12. And C was at 4, 12. And when I multiply them by a scale factor of 3/4, I'll get my A prime, B prime, C prime. So 8 times 3/4. 8 times scale factor of 3/4. That's going to give me 6. -2 times 3/4. Pull out my calculator. Going to get -3/2 or -1.5. -6 times 3/4. Going to get 4.5. Twelve times 3/4 gives me 9. 4 times 3/4 gives me 3. And 12 again times 3/4 gives me 9. So I'm just taking all of my original points, A, B, and C, and multiplying them by 3/4 to give me A prime, B prime, C prime. So these are going to be my final answer. Line segment XY is 5.2 units long. If XY is dilated by a scale factor of K equaling 4.7, what is the length of X prime, Y prime? So all I'm doing is I'm just taking my original length, 5.2, and I'm multiplying it by my scale factor, 4.7. So 5.2 times 4.7 that's going to give me 24.44. So line segment XY or X prime Y prime is 24.44 units long. Number 3 says, identify the type of dilation and find the scale factor, reduction, or enlargement. So anytime you're doing a dilation, you're either making your figure bigger than it was when it started, or you're making it smaller than it was when it started. And so our scale factor K, all right, we just usually typically work with scale factors that are bigger than zero. So if your scale factor is between 0 and 1, so if it's a decimal or a fraction, then it's going to be a reduction. And if your scale factor K is bigger than 1, it's an enlargement. So if we're looking at this figure right here, then I want to pick a pair of sides that are matching each other that is easy to count. So you can see here I've got HG my original figure is right there. And then I've got H prime, G prime. I want to match them up with like sides, okay? So we always start with the one without the little prime notation. So H prime, G prime, that's going to be our image. HG is our pre-image. And we got to try and figure out what the scale factor is. So on HG, we can see that it's 1, 2, 3, 4 units long. H prime, G prime is 2 units long. And in order to get our scale factor K is equal to image divided by pre-image. And so if my image is 2, my pre-image is 4, then my scale factor is going to be 2 over 4, which just reduces to 1/2. So in other words, H prime, G prime, or that figure right there, is half as big as its original counterpart, the one down here. Number 4 says, what is the rule to describe the transformation pictured? So we got to write our rule. I'm going to write the rule both in coordinate and function notation. Okay. So the first thing I'm going to figure out is what is my scale factor. So remember, scale factor K is image divided by pre-image. Okay. So I'm going to pick 2 side lengths that correspond with each other that are easy to count. And you can see IH is just a horizontal line that's easy to count, right? So IH and I prime, H prime. So if I count the sides, IH is 1, 2, 3, 4, 5 units long. And then I prime, H prime, 1, 2, 3, 4, 5, 6, 7, and maybe about a half, so 7.5. Okay, so my image is the bigger one here. It's I prime, H prime. So I'm going to say it's 7.5. And then pre-image was 5. 7.5 divided by 5, that's the same thing as 3 over 2 or 1.5. Okay? So when I'm writing my rule, okay, I'm going to write it in coordinate notation. Remember, we always start with XY in coordinate notation. XY, and then it becomes K times your X, and then K times your Y. I saw a common mistake on the quiz. People would just write it like this. You need to replace that K with whatever your scale factor is. In this case, my K is 1.5. So I'm going to replace that K with a 1.5. So that's my coordinate notation. Then function notation. We just write capital D for dilation. And then we write subscript, we write a 1.5 for our scale factor. Number 5 says, determine the rule of the dilation below, expressed in coordinate and function notation. So whenever you're given a pair of matching coordinate points, first figure out which one is your image and which one's your pre-image. So T is my pre-image. That's what I started with. T prime is my image. Is what I ended with. And so you just want to pick a pair of points that match with each other. So I'm matching T and T prime, and I'm going to look at the X values. So 1 and 0.5. So I got to find my scale factor first. Remember, image divided by preimage. And so image in this case is 0.5. So I'm going to put 0.5 on top. And then preimage is going to be the 1. So if I reduce that, 0.5 divided by 1, that's the same thing as 1/2, or just 0.5. Okay. Now, for coordinate notation, I've got start with x, y, and I'm going to end with 0.5x, 0.5y. Okay, it's our scale factor times x, and then scale factor times y. And then for function notation, I'm just going to have d 0.5. Number 6, it says dilate IJKL centered at the origin and graph the preimage. So I have a dilation, a scale factor of 0.5, okay? 0.5 is our scale factor here. And so it gives us all of our preimage points, I, J, K, and L. So the first thing I'm going to do is I'm going to plot all of these preimage points. So I is at 1, -1. J is at 1, 2. K is at 5, 0. L is at 3, -3. Make sure I label all of these points. And then it tells me that my scale factor is 0.5. I'm just taking this scale factor and multiplying each of my points by 0.5. So to get I prime, 1 times 0.5 is going to be 0.5. Same thing for -1, it's going to be -0.5. J prime, 1 times 0.5 gives me 0.5. 2 times 0.5, that gives me 1. K prime, 5 times 0.5 gives me 2.5. 0 times 0.5 gives me 0. And then L prime, 3 times 0.5 is 1.5. -3 times it is -1.5. So now that I got all these new points, I'm just going to plot those too. So I prime is at 0.5, -0.5, about right here. J is at 0.5 and 1. K prime is at 2.5, 0. And L prime is at 1.5, -1.5. About right here. And then make sure I label each one of these points as well. All right, number 7 says justify and state if the two polygons are similar. So in order to be similar, all corresponding angles need to be congruent. So all corresponding angles are congruent. And you can see here that they've already marked those for us. So this top left angle is congruent to this top left right here. It's kind of rotated, so you got to look at it as it's corresponding. So this one in the bottom matches this one in the top left. Same for this one in the top right, matches this one over here. And so all these angles correspond with one another, okay? So we can check that one off, all right? And then the other thing we need to check is that all corresponding sides are proportional. All right. And so what we mean by that is we're going to take each corresponding side and set them over each other in fraction form. That'll create ratios, and all of those equal each other, then that means they'll be proportional. So I'm going to say this side 8 matches this 48. So I'm going to say 8 over 48. Or better yet, I'm going to make it 48 over 8. It doesn't matter which way you do it, so long as it's the same way for each one. I'm going to do 48 over 8 because it's going to give me it's not going to give me a decimal, and it makes it a little bit nicer. So 48 over 8. So I did big over small. So now I'm going to do 31.9 over 4.9. And then I'm going to do 4 and 22. So it's going to be 22 over 4. And then the last one, again, we have 31.9 over 4.9. And so if I reduce all of these fractions, then they should equal the same thing. So we've got 48 divided by 8. It's going to be 6. And then if I do 31.9 divided by 4.9, let's check here. I'm going to get about 6.51. All right. So I don't even have to continue working. I can just immediately stop here. And because I know, well, these two numbers are not the exact same thing. 6 is not equal to 6.51. I don't even have to do the other two, because if these don't match, it doesn't matter what the others do. So this does not work. And since it doesn't satisfy both parts, we can say that these are not similar. All right. Now, it says a tree casts a shadow 24 feet long. At the same time, a 5-foot person casts a shadow 8 feet long. How tall is the tree? So we have two similar right triangles, okay? And we got to figure out how tall is this tree. So what I'm going to do, I'm going to break this down into two triangles. We got the big triangle for the tree, and we got a small triangle for the person. Okay, so the one for the person, it says that they are 5 feet tall and their shadow is 8 feet long. So I'm going to rewrite this over here as 5 feet tall, 8 foot long shadow. And then for the tree, it told us that its shadow is 24 feet, but we don't know how tall the tree is. So I'm going to put 24 feet for the shadow, an x for its height. And so now I can create a proportion to help me solve for this unknown height. So I know that x is the height for the tree, and 24 is its shadow, and the person is 5 feet tall with an 8-foot shadow. So I'm going to create a proportion. I'm going to say x over 24 is equal to 5 over 8. And the way we get rid of those fractions, cross multiply. So I'm going to say 8 times x gives me 8x. 24 times 5 is 120. I'm going to divide by 8 on each side. And so x is going to equal, I believe that's 15, but let me check. Yeah. 15. So that tree is 15 feet tall. All right, number 9, it says the pair of polygons are similar. Find the missing side. So we already know that these polygons, these quadrilaterals are similar, okay? I just need to figure out how big this missing side is. So I'm going to create a proportion using like sides, corresponding sides, right? So I've got 12 and then the unknown side compared to 18 and 21. Okay, so just the same thing as we did on number 8. I'm going to say 12 over, I don't know what that side is, so I'm going to call it x. And that equals 18 over 21. And then how do I get rid of the fractions? Cross multiply. So I'm going to have 18 times x, that gives me 18x. And then 12 times 21, that gives me 252. Divided by 18. And that gives me x equals 252 divided by 18 gives me 14. So that missing side length is 14 units long. Find the missing length indicated. So we don't know what this length is right here. I'm going to call it x. Now, you'll notice these arrows on these two line segments right here. What that tells me is that both of these line segments, this one right here and this one right here, are parallel to each other. And anytime you have two triangles where a pair of the sides are parallel, then you could say that the other two sides are cut proportionally. And so we can just immediately go ahead. We see that this side length is 4. The whole thing is 6. And then on this one, we've got 8, and then the unknown side, x, right? And so what I can do is I can just immediately set up my proportion using those measurements. I can say 4 over 6 is equal to 8 over x. I did small over big equals small over big. And so now that I got my proportion, how do you get rid of the fraction? You can cross multiply. So 4 times x gives me 4x. 6 times 8 equals 48. Divide by 4 on each side. And so now I've got x is equal to 12. Number 11 says find the missing length indicated. So we don't know what this length is right here, so I'm going to call it x. And then the same concept can be applied to this one as well. Because these lengths are parallel to each other, even though it's not a triangle, it still cuts all of these parts proportionally, okay? So I know that this whole length right here is 15. This whole length is 15. And we have this unknown side, which is x. So I need to compare it to other things on this side. I got 12, and I don't know what this part is, but I do know that since the whole thing is 12, this little part is 4, that means this part has to be 8, because 8 plus 4 is 12. So now I can set up my fractions. I can say 15 over x is equal to 12 over 8. Get rid of the fractions, I cross multiply. So I've got 12 times x gives me 12x. 15 times 8 is 120. Divide by 12 on each side. And so x is going to equal 10. Number 12 says the pair of polygons are similar, find the missing side. And so compare like to like, right? I don't know what this side is over here on the right side, but I got to do a little bit of work. I got to figure out, okay, which side matches with what, because they're not sitting in the same direction. But if I were to say this triangle on top, if I were to rotate it so that it's sitting the same way as the bottom one, I would see that 24 and 9 match with 35 and x. All right? So I can say 24 over 9 equals 35 over x. And so if I want to get rid of the fractions, I cross multiply. So I'm going to have 24x is equal to, I think it's 315. Yeah. Equals 315. And then divide by 24. And so x is going to equal 315 divided by 24 is 105 over 8, or the same thing as 13.125. Number 13, find the missing length indicated, leave in simplest radical form. So we've got three sets, or a set of three similar right triangles. So anytime you have something like this where it gives you an altitude, you're going to want to rewrite or redraw each of your triangles individually. So we've got a big triangle, we've got a medium-sized triangle, and we've got a small-sized triangle. So on the big triangle, the only thing they give us is this side right here. X and 9 combined is x plus 9. On the medium triangle, so this one right here, we've got x is this side, and then 12 is this side. And then on the small triangle at the bottom here, we've got 12, which is this left side, and 9, which is this bottom side. And so they only give us one piece of info on the big triangle, so I don't actually need that one for this, but I'm going to focus on the other two. On the medium triangle, I got x and 12. On the small one, I've got 12 and 9. And so if I'm creating a proportion, I can say x over 12 equals 12 over 9. Cross multiply. 9 times x gives me 9x. 12 times 12 is 144. Divide by 9 on each side. And so x is going to equal 16. And then the last one, find the missing length indicated, leave in simplest radical form. Same type of problem. I'm going to redraw each of my triangles individually. So we got a big triangle, we got a medium triangle, and we got a small triangle. On the big triangle, okay, so they give us the bottom, which is 60, and then the entire length is x. And so sometimes you have to keep reorienting these triangles. So I basically rotated it this way to help me set it up upright, looking like this. And then so on the medium triangle, so this one over here, the only thing, they didn't give us anything directly, but I know that this whole length is x, this is 36, so I'm going to say that this is x minus 36. So on the redrawn triangle, that would be this side, x minus 36. And then on the small triangle, they give us the bottom, which is 36, and then they give us the hypotenuse, which is 60. And so the middle triangle, it doesn't really give us enough info, so I'm not even going to worry about it. But on the other two triangles, I have x and 60, and I have 60 and 36. So to set up my proportion, I can say x over 60 is equal to 60 over 36. Solve for x, I'm going to cross multiply. So I've got 36x is equal to 3,600. Divide by 36 on both sides. And so 3,600 divided by 36, that's going to give me x equals 100. All right, and so that's the entire test review, okay? If you're looking for any extra practice, don't forget we have Delta Math. Some of you may have already been working on it, which is awesome. But if you would like some extra practice, there are Delta Math problems on there. We have a code for it on our Canvas page. So make sure to check that out if you're looking for any extra practice, okay?